Welcome to this exciting event this afternoon, and it's morning in the Bay Area. So good morning for everybody joining us from the Bay Area. So this is an event co-organized between Georgia Tech and Berkeley, and we are very happy to welcome a team from the New York Times who will talk about how to use emerging technologies in the service of journalism and how they've executed on this at the New York Times. And so there's a whole team, but I'll just introduce at this point the head of the New York Times R&D team, who will introduce and intern his team members. And that's Marc Lavallee. So he's has a storied career in tech and journalism at the Boston Globe, at the Washington Post, and also at NPR before he joined the New York Times. And he joined the New York Times about 4 years ago, or 9 years ago, sorry. And about 4 years ago, he started this new effort at the New York Times, which is this R&D department on how to use technologies like photogrammetry and 3D reconstruction, all things that we care deeply about as academics. And it's great to see these tools being used in that context, and we'd like to hear about how we can do better in providing these tools to them and see how they're used. So, Marc, super excited about this, and please take it away.
Yeah, thank you, Frank, and everyone for having us today. We're super excited to show you some of the things that we're working on. So as mentioned, I'm Marc Lavallee, and we started this, Marc, McKeague, and I started this R&D group at the Times about a little over 4 years ago, right before an election that we thought was going to be uneventful. We go off and sort of like think about the future of journalism a bit. So we've grown it considerably in the intervening time. It's about 24 people now working in a variety of areas. We're going to walk you through some of these explorations and some of the work that's seen the light of day. And we have a good roster of folks representing the team today. So I'll just mention Mint, Lana, and Marc, and in that order. Ask everyone to introduce themselves.
Thanks, Marc. Hey, everyone. My name is Fleisher. I'm a senior engineer on the R&D team. I work primarily on spatial journalism explorations, which include computer graphics and some computer vision. And I'm really excited to be here today.
My name is Marc McKeague. I'm a technical lead on the R&D team, and I'm a mix of a designer and technologist. And yeah, I've been working across computer vision, some ML projects, and across a lot of different interesting emerging tech we've been doing, and excited to share with you.
I'm Lana. I'm the creative director for R&D. I work on both envisioning and designing ways for New York Times journalists and readers to understand and interact with the tools that we're building. I'm very happy to be here.
And Mint may be having some internet issues. She was dealing with some stuff. But before this, so just to mention her briefly, she's a creative technologist with the team and has been specializing in a lot of the 3D capture work that we've done, particularly in the field with a technique called photogrammetry that we're going to show. So she and Lana are going to talk about photogrammetry a little bit later on. Marc has some great stuff at the intersection of computer vision and sports, particularly around pose estimation, and has some great stuff on work that we're doing in 3D visualizations, and particularly making that work in AR as well. So before we get into the cool stuff, just to do a little bit of a quick setup about how we work and what we're doing. R&D even in media can mean a lot of different things. There are a lot of different types of groups at news organizations set up to really sort of meet the needs of a respective organization. It's not really a one-size-fits-all approach, at least in this era. The way that we've set this up at the Times is to really look at the next 2 to 3 years. What do we see coming in terms of emerging areas of emerging technology that we think have some tangible application in the service of journalism? What's starting to feel real? What are we seeing in adjacent industries? And what do we think we can actually use in production in that time frame? And so it's very much at the applied end of the spectrum. We're really looking at ways that we can shape our storytelling in ways that you can actually see. I think a little bit different from a group that might be thinking 5, 10 plus years out. We work very closely with the newsroom to make that a reality. So we want to really understand what problems they're trying to solve, what stories they want to be able to tell for our readers, and be able to work very closely together. But part of the way that we designed this is that we're not really on that treadmill of news all the time. There's a lot of storytelling innovation that happens in the newsroom proper. But one of the ways that we set this apart in being able to look out a little bit further out is how we can be having this conversation the Friday before an election, as opposed to being in the weeds on exit poll visualizations or whatever our colleagues are working on this afternoon. We do a lot in that, working closely with other groups to identify those problems, so that we avoid a space that R&D teams can sometimes fall into, of creating solutions in search of problems. We want to make sure that our work is very targeted toward what we're trying to do with the newsroom. There's a lot, obviously, in the rapid evolution of machine learning, particularly with computer vision and natural language processing. That's been a big area of focus for us over the past couple of years. We also look at larger trends like the rollout of 5G, which is obviously a multi-year thing, and try to anticipate how we can take advantage of these things as they start to become real, both for reporters in the field and also readers, at home and on the go as well. So while we're not out there installing radio equipment and things like that, where we've been working for the past couple of years on understanding how we can take advantage of those capabilities as they become more widely available. So a little bit of the work that we do is a little bit adjacent to that. Writ large, basically, if there's a buzzword of emerging technology, we've probably done some kicking of the tires with it. We have a pretty broad remit in that regard, and so the team that we have working on these things has a good collection of journalists and technologists of various disciplines, as well as designers and strategists to really round this out. So we try to be pretty cross-functional in how we organize our work and the people around the work as well. One thing I wanted to touch on, just sort of categorically about how we approach these things, was obviously a lot, particularly in the realm of machine learning and artificial intelligence these days, in terms of making sure that models are developed and deployed in an ethical fashion. I think as we've worked through this over the past several years, it's been interesting how closely these questions that are really emerging in this space align with what are pretty traditional questions about ethics in journalism as well, about making sure that you understand who your sources are and where that information is coming from, but also protecting both your sources and that information, and then also the reader's needs and interests at the same time as well. And so I think as we've worked through a lot of areas of emerging tech and some things that are somewhat controversial, like facial recognition, it's been helpful to be able to do this in a newsroom setting for two reasons. One is that we have a very strong standards desk that's been around for decades, that is very accustomed to dealing with these kinds of questions, things that we're trying to figure out for the first time, whether it involves a technology or not. They definitely manage a lot of the exceptions in our news report. And then two is that when we're looking for specific stories to be able to try new technologies out on, we can kind of create a bounding box of a safe space to be able to do this work, where we don't have to worry as much about what would be like internet scale implications of adopting a technology, and we can make these things be really sort of concrete and tangible. So the example you're seeing on the screen here is some work that we did with the royal wedding I guess the wedding was of royals at the time. I guess they're now not really royals, with Meghan and Harry. and working with real-time facial recognition of the attendees and being able to immediately identify these folks. A lot of these folks are pretty famous. A lot of people know what Elton John looks like, but be able to work on a feature that immediately would add lower thirds to the screen. So you were able to answer the question that's formulating in your head as you see George and Amal Clooney show up, which is like, why are they there? To be able to do this in a setting like this, where we're talking about well-known people and at a public event, we didn't tag any of the children. It's a limited set of people, so we can really guard against any dangers of false positives or things like that. It's sort of the example of a way of being able to work with a technology like this, where the consequences are any negative consequences are sort of minimal, and this helps us really be able to understand what is happening under the hood with these things in a way without sort of releasing a tool into the wild that could be used in other nefarious ways. And so that's I think that's part of how we approach these things. Now, even with that, even in evaluating the technology, there you take an example like this. We felt comfortable doing this at the time. I guess three years ago now. One of the things that we need to do as a news organization is really think through any implicit endorsement of technologies that might sort of stem from the work that we do publicly. And so, if we were looking at a similar event coming up next spring, let's say, we would definitely look at the world as it exists and our understanding of the technology as it exists at that time, and we might make a different decision even if the technology is largely the same. So long story short with this, it's that a lot of these things are very much moving targets for us, and being able to hook the work that we do into a newsroom, I think really helps us make sure that we're doing the right things in the right ways at the right times. So obviously we could spend a whole afternoon on the ethics stuff alone, but I think to be able to show some cool stuff here, I'm going to hand it over to Marc to talk about some computer vision.
Thank you. And so I think we see a lot of potential in computer vision for use in journalism and reporting. I want to walk you through one specific example, is looking at sports, and in particular, analyzing the performance of athletes. And just to give you some context of like why the New York Times would do this, we have a long history of showing you how and why athletes do the things they do, or maybe more how, and in interactive and engaging formats. So this, what you're looking at right now is, Justin, can you go back to the previous slide? Is a photo montage created from the 2019 gymnastics championship. And so we use burst photography to analyze her floor routine, and this is her historic triple-double. And we can take you through frame by frame and tell you like what what normally happens in a few seconds, and break it down piece by piece. And we've been doing this for a while. On the next slide, you'll see some work from my colleagues from 2016, where we took Simone Biles and actually went to a training center. We attached some like sensors to her, and that powered this interactive where we like walk through and could show you in 3D what her moves were. But what else can we learn from performances without even having to strap on sensors and make a specially planned piece in advance? Like, what can we learn from quantifying her actual winning performance, and could we gather more metrics and information from that? So we started formulating a plan. We started to look at the latest advancements in computer vision, particularly around pose estimation, but also around all the other parts of the tech that you need to do something like this. And we sort of aligned on this plan. And I can walk you through it. Starting off with actually capturing the information, we landed on an approach which uses burst photography to capture photos of the athlete when they're doing their routine. So photos are good that you can adjust the shutter speed. When we worked a lot with video feeds, often they're moving so fast that to get the exposure that it's actually blurry. So we would like very accurate information from each step of the routine. Then once we have those photos from multiple angles at the exact same time, we estimate all the 2D poses of the people that are visible in the frame. That information is still as useful, but it's still not enough to understand where this athlete is in 3D space. And because we're trying to do this at live events, we're not able to calibrate a system in advance. So we're relying on our access for our photographers who can be there on the day off, potentially the day before. But we developed a technique, also like building upon research, to use like the standardized sizes that sports equipment are as known objects in the space, and then we can determine the position and rotation of the camera on the day off. Once we have all that information, we can use that to triangulate the 2D poses into a 3D world space. And then essentially we've got the thing that we've been working for so long, is this sequence of 3D poses. And with that, we're able to accurately tell you like how high they jump, what is the speed of their rotation, and also visualize in a frame-by-frame basis what the athlete's pose was at that point in time. So let me get a little bit deeper. Like this is actually a pretty big challenge. One, with still photography, making sure your photos are synchronized is really tough. So we developed some hardware that basically connected these cameras together on a local radio network with a synchronized time from beforehand. So first, the photo that you're seeing is when we conducted field tests early in the year, a practice session of Rutgers women's gymnastics team. And so that was like our first and turned out to be our last capture due to the coronavirus. I think we were at their very last practice session. So once we have all that media, so it's basically a series of burst photos that we can synchronize and line up, we get that 2D position. So Justin, you can move to the next slide. And this is what, that one previous. Yeah, so this is what it looks like. Oh, this is what the final output looks like. It's a looping video. First part of the video is that you're seeing the 3 photos with the 2D pose overlaid. And then this is a clip of the actual 3D output. So another challenge we have, especially within the practice arena, is that the 2D pose estimation model is actually picking up all these people in the background. We have to first tell it which pose we're looking for, and then we can use basically a technique that we track the distance, the closest pose on the next frame, so we can keep that continuous pose throughout the scene. So on the next slide, we are taking a look at using that known geometry within the scene. And basically, with the balance beam, we know that the length and the depth, the height of the balance beam in advance, it's internationally standardized. We create a very basic 3D model of that, and then when the camera is set up, you have to do this one-time calibration of where those points are in the 2D image space. So that's what you're seeing there. And then if the camera is static, that remains consistent throughout the entire capture. Go to the next slide. We discovered a lot with pose estimation that often the poses in gymnastics are pretty extreme, and a lot of pose models are built on people generally being upright and walking around rather than these extreme positions. So we actually worked with a lot of different models. We actually ended up with one, which is the data from here from a company called Wrench, which actually works pretty well in most scenarios. But it was very important to us that we get accurate data. So we had to approach that with our tooling and our pipeline. There's an opportunity for a human to go in and like correct the data so that we get the most accurate, so we can trust that this metric that we're given or this 3D visualization that we're having is representative of what actually happened. And I think this is important that a lot of machine learning tools that the New York Times builds, which is a little bit different when you're working on the actual proving the efficiency of a model, is that we want to be able to put the human in the loop to make sure that the outputs are accurate. Is the next slide. So this is some of the information that we can get. So this is from the practice capture. So basically, we can pick points that the pose estimation is pulling out, and then we can give you the height from the balance beam, and also we could do rotation or speed. So it's depending on the athlete, we can like adjust the analysis and like get it essentially while we're we set this up in a way that you can develop this pretty rapidly. And right now we're exploring how this capability may be used in future coverage. So we were originally targeting the Summer Olympics this year, but we're definitely looking towards what we can do at next summer's Tokyo Olympics. But also, this is just one part of a larger research area for us. So we're looking at other ways that computer vision can be applied on video, on photo. And so you can check out on our website, we have a computer vision section where we're going to be posting, or continually posting new updates in this area. So next up, my colleague Orr will walk you through some of our work in 3D and spatial journalism.
Thanks, Marc. Hey, everyone. I'm Orr Fleisher, an engineer on the R&D team. So over the last 2 years, the New York Times newsroom has produced groundbreaking augmented reality experience. I'm not sure if anyone had the chance to check them out, but anything from recreating the Apollo 11 moon landing to using AR to visualize CDC guideline. Our work in the spatial storytelling domain has really demonstrated journalistic potential of spatial computing. And so as an R&D team, we are further exploring this opportunity and trying to imagine what it could look like for New York Times journalism to push the boundaries of spatial storytelling. So questions like, how can we use data visualization to tell stories that couldn't have happened in 2D? What does it mean to actually use the space around you to tell stories? And how might the time journalism appear as a contextual layer on top of the world via phone-based AR or AR glasses in the future? And so the first project that I'm going to walk through is actually a project where this is a project where the R&D team worked with the graphics desk at the time, and we helped visualize data from a simulation done at the Kyoto Institute of Technology in Japan. During the peak of the outbreak in New York City, just to be fully explicit, during the peak of the outbreak in New York, we helped visualize a cough particle simulation. Basically, we helped build a render pipeline that is able to visualize how far a cough could spread in a space. So in order to do that, I'm going to dive a little bit into the technical stuff, but I feel like it's probably the right crowd. So we built a cloud pipeline that ingested the research files, which were done at the Kyoto Institute of Technology in Japan. These were exported as VTK files, and then we essentially built a layer of infrastructure that ingested the research simulation and pre-processed it, filtered it, cleaned it up, and packaged it into an ASCII format that we can then use in 3D authoring softwares like Maya to do the interactive article, but also the newspaper version of it. And this was important and crucial because we were able to optimize the delivery format of the research data into something that could be rendered in a real-time engine. And so this is kind of a little snippet of what the data looks like. This is the data visualized in pair view. So prior to us actually processing it, it's a simulation sequence over time of how droplets and aerosols spread in the air. You can kind of see the heavy droplets sinking down, and this was what eventually was used in this story. Yeah, so this is another example. This is a great moment to show Jupyter Notebook, but this is another example of the pre-processing phase where we basically used a pre-processing phase to be able to color the particle in the visualization differently by their micrometer width. And so our pre-processing phase ingested the data, took out the diameter of each droplet, and was able to put a class for each one of the droplets inside of the ASCII representation such that the visualization component could read that and visualize the particles accordingly. And this is sort of in the pre-processing phase because we had to work with 3D authoring softwares that didn't support point cloud representations. We actually gift wrapped each one of the point clouds, triangulated it into a mesh such that it could be read and the story could be designed in Maya, but then the point clouds would be rendered by the engine accordingly at the end. So it created some really interesting shapes, as you can see on the bottom right. And this is what the visualization looks like in the story. Yeah, Justin, maybe we can skip to the next slide. And this is what the visualization looked like in the paper. For us, it was really important to build a data pipeline that would be able to support the newsroom in both the interactive formats and the print formats. So along with the story, we also published an AR effect in our iOS app where the effect would basically visualize the CDC guidelines. This was very early on in the outbreak, and so it actually almost felt like a real thing. Shooting the videos for this effect felt very real. It was hard to actually get people to come into the frame in some scenarios, and then the opposite in other scenarios. So this video definitely conveys the augmented reality layer of this story. So a little bit differently, the second example I'm going to run through is actually an augmented reality effect we published on Instagram. So we definitely have an augmented reality layer in our app, but we also publish augmented reality effects into Instagram, and I think they cater to slightly different types of readers. And so it's by itself is an interesting thing to talk through. So this effect visualized how air pollution levels had dropped during the peak of the coronavirus lockdown. And so what we did is we built this data ingestion mechanism again that would take PM 2.5 readings from Berkeley actually, and would pre-process them and prep them for an augmented reality effect that uses a particle system to basically let you toggle between before lockdown and during the lockdown to see how air pollution levels dropped in 4 different cities around the world. So what you can see in this looping video is actually visualizing New Delhi, and you can kind of see that we built a way for the particle system to be able to react to the data, the max average prior to the lockdown, and then the max average during the lockdown. Yeah, so we're really excited about continuing to push spatial journalism forward. I think the things we're thinking through are how can we build more data visualization pipelines? How can we build simulation data ingestion pipelines? How can we represent data in 3D? And how can we push spatial journalism as a format forward? Yeah, this is a sort of a part of some of the stuff that we're working on. Just to tease out a little bit of what might be coming next, we're looking into how cartography could play a role in spatial journalism and how cartography could play into augmented reality to be able to tell stories about places. So this effect shows basically a 3D tile of a map of Grand Canyon that you can explore, and we're really excited to publish some of this work out in the near future. Next up are Lana and Mint, who will share on how we're pushing the boundaries of storytelling with environmental photogrammetry.
Thank you, Or. So I'm Lana. I'm the creative director for R&D. And one of the goals of journalism is to bear witness to history as faithfully as possible. And this is especially true for photo and video journalists who really put themselves on the front lines in order to visually document events. Visual journalists are always looking for new technologies to help them capture more detail and get the news out faster. But they've been operating within the constraints of a camera lens, which, as we know, is a 200-year-old technology, and it gives readers really a single 2D representation of an event. The Times published its first photo in print in 1896. I think this next couple of slides will show you the progression over time. So the question that we're asking is what if we could break free or break out of this rectangle and let readers experience a place the same way that a journalist did? So instead of actually sort of just looking at a photo of a space, what if we could actually move through it? So environmental photogrammetry allows readers to experience an entire space as if they were there. And because we can represent the space fully in 3D, that allows us to show it from really any angle, which gives us a completely new way of framing and guiding the story, and multiple ways of framing and guiding the story. So last year, our team started to think about what it would take to actually embed these 3D models in a Times article page, and how readers would interact with them. So until now, most interaction models would simply sort of drop a user into a 3D space and force them to decide where to click or how to move around. But we felt that experience could be really disorienting and kind of counterintuitive. I think too much freedom in a space or too little guidance can leave readers really wondering what information they're supposed to get out of the space. And we also didn't think that approach would scale to millions of readers. So our solution was to borrow an interaction that we know readers are familiar with, which is scrolling. So as the reader scrolls down on an article page, we navigate them through the 3D scene and stop along the way to highlight points of interest. So if you want to go back, you can simply scroll up. And if you want to go faster, you can scroll faster. Our user testing kind of validated that this was an intuitive way to experience these large-scale 3D environments. And once we're able to establish a level of comfort in the space, we can then introduce opportunities for readers to explore it more freely. So we've multiple environmental photogrammetry models that integrate these interactions, and the feedback has been overwhelmingly positive from readers. So what you see here is a walkthrough of Jackson Heights, Queens. And then the next example, and the next slide, which might get it to load, is the house of the e-gamer conglomerate FaZe Clan. Give it a chance to run through a little bit. Mint is going to walk you through the process of using environmental photogrammetry to actually generate these 3D models.
Great, thanks, Lana. Hi, everyone. My name is Mint. Sorry about the internet problems. Now I'm back. I'm a creative technologist in the R&D team. So as you've seen, one of the main 3D capture techniques we are exploring at the times is photogrammetry, which is a process that involves taking hundreds or thousands of still photographs and using software to stitch them together into a 3D model. The software looks for areas of similarity between photos and then uses parallax or the relationship between objects in the foreground and the background to create depth. Photogrammetry as a technology is not something new. Other industry like gaming and film has been using this technique to create photorealistic settings for some time, but it can take them weeks or even months to create the model of this size. And as a news organization, we typically only have days to deliver the content to our readers. So we have to be creative in exploring to optimize this workflow. Publishers, including the Times, have used photogrammetry to show 3D objects in great detail, but have been constrained by the bandwidth required to make larger environmental scale models accessible to readers. The R&D team has been working to overcome these technological challenges so we can bring bigger and more ambitious models in our journalism. Over the last year, we have made several breakthroughs on the scale, the speed, and the delivery that will enable us to do just that. On September 1st, 2019, Hurricane Dorian struck the Great Abaco Island in the Bahamas. In the days that followed, the R&D team traveled with the Times graphics departments to document the aftermath in Sandbanks, a shanty town where many Haitian immigrants live. The result is a model that reveals the overwhelming physical realities of a disaster of this scale in a way that most people have never experienced before. To efficiently generate a 3D scan of these massive spaces like sandbanks, we learned that we need to limit the number of photos we take, set a pre-planned capture map path, and make sure that the photos taken from photo A to photo B have at least 60% overlap. When in doubt, 80%. The photos are taken in RAW, and then we color correct the RAW images into the linear color space in JPEGs. Then these images are used as the source files to create the 3D mesh in a software that we use called Reality Capture. Having a strategies like these not only drastically reduces the amount of time it takes for the software to process the files, but also make sure that we deliver large-scale models within the news cycle. Next slide, please. Delivering these models to readers was another huge problem because of the massive size of the files. Downloading scenes made up of billions and millions of polygons and textures is just not practical. We needed to build the technical foundation for readers to stream this model in the same way we stream movies. Our solution was dynamic delivery, which allows users to load only what they see as they scroll through the model and optimize for the particular device and bandwidth. So when you zoom in, we only load what you're looking at and discard the rest. By loading only what you're seeing, we are able to optimize the model for mainly performance reasons and maintain high accuracy of the geometry created. The Sandbanks model that you saw in the previous slide has a 1.5 millimeter accuracy. What this number means is any geometric details that are smaller than 1.5 millimeters are optimized and discarded. So we can go even smaller than that, but after doing many tests, this is the optimal value that allows us to maintain a pretty good level of detail in the model while preserving or even improve performance quite a bit for the article. Next slide, please. Okay. So another interesting technique we are doing on the delivery side is color correction in real time. So previously, our workflow involved a lot of back and forth internally between our team and other desks within the New York Times. For example, let's say that the editors wishes to stylize the look and feel of the model to match the story that they are working on. We have to export the new batch of the images from RAW, upload them to the cloud, distribute them to the computing machine, run another round of texturing process in the photogrammetry software, export the models, and then finally upload it to the cloud to see the final results. That process can be extremely cumbersome when there is more than one change, and leaves us being blocked by a decision that could happen very close to the delivery date of the story. So to go around this issue, we implemented a color correction in real time in the post-processing delivery side using the lookup table technique in combination with the 3JS platform. So the lookup table, also known as LUT, is a colorful grid-like image at the bottom that you're seeing. It tells the computer how it should modify the color of each pixel in an image. So now we have a LUT, right? We create a LUT image for the model. And it's going to determine the style for all of the nicely UV unwrapped texture maps that compose the entire scene. We can tweak this LUT image as many times as we want and see the results applied to the model instantly. Making changes in a single lookup table image in the library side versus applying changes to the raw images save the production team about 1 to 2 days of work for around 1,000 to 2,000 images, 60 megapixel images. It also provides flexibility for editors to decide how they want the model to look like later in the process as the story progresses. Yeah, next slide. Okay, this is good. We are constantly learning from every project we work on and thinking of potential adjustments we can make to our 3D scanning ecosystem that will allow us to deliver higher quality content in less time. There's a lot more to be done, especially in the capture process and the delivery pipeline. In terms of capturing the 3D scenes, we are also looking at other 3D scanning techniques that have proven to be beneficial in our workflow. A particular one is called LiDAR, a scanner that uses lasers to send out pulses of light and times how long it takes each pulse to return to its source. Using LiDAR in combination with our core photogrammetry methods can merge together of both worlds. The long-range accuracy of laser scans is complemented by the high-resolution texture and color of the photography, and thus creating geometry precise model with detailed texture. In regards to how we can reduce our production time, one research topic that we are super excited about is to be able to align images in real time in the photogrammetry software while a photographer is still at the capture site. So not only you will be able to see the photos as soon as they are taken, but the photographer will also be able to see the 3D preview of the model as it is being processed. In having this instant feedback both ways, we can ensure that the photographer takes enough images for a good mesh and does not miss any blind spots. This will be incredible because it can reduce a ton of manual labor work, fixing corrupted meshes and artifacts left in the model due to not having enough photographs taken. It will also make things easier for the photographer side, since sending and receiving thousands of large photos is a very time-consuming task. Beyond that, we are also experimenting with new forms of 3D storytelling. We are looking into ways of implementing artist capturing techniques like volumetric capture or 3D60 videos into our visual journalism. That will enable us to add movement into the scene and make the story even more engaging. Developments like these would open up so many possibilities in terms of storytelling for our newsroom, and we're more than excited to be able to collaborate with them to tell stories in a new way. Back to Marc.
Yes, thank you. Cool. So I think just a couple of things to wrap up on here before we open up to Q&A. I think open invitation to share any of the research that you are working on. I think what we've learned over the past couple of years is things that are being explored in adjacent industries and adjacent spaces have a lot of times some relevance to journalism. So even if it's not necessarily with journalism in mind, we're always eager to hear about what folks are doing and in other spaces and helping to connect the dots. And that's a two-way street as well. So thinking about how the work that you're doing can possibly have some impact or effect on journalism. We're always eager to help kind of find ways and homes for that, whether that ends up working with us or others in the industry. There are a lot of challenges and interesting problems to be solved and worked on in this space, both nationally and internationally. There's a pretty good community, particularly on the computational journalism side of things. So always eager to help kind of participate and route things there as well. And then third, we are always looking for interesting, talented folks who want to join the team and be part of this work with us, both as through an internship program. I think we're going to have 3 seasons, spring, summer, and autumn internships coming up in 2021. We're going to have, I think, the spring and summer posted very soon. So be on the lookout for that. And then also we have a few openings. This is for the future, after you graduate and all that, for machine learning in particular. But beyond R&D, there's a lot going on at the Times that's incredibly interesting and impactful as well. So if there's any way that we can be helpful in sort of guiding and routing any interest you might have in working at the Times broadly, we're always eager to help with that as well. And so all this stuff can be found at our website, rd.nytimes.com. And we're on Twitter. We're pretty findable. So eager to hear anything that's on your mind. And I think with that, we've got some time for questions.
All right, well, let's clap. I think, Anju, do you want to start and introduce yourself?
Yeah, sure. Thank you so much for the exciting talk. My name is Anju Kanazawa. I'm an assistant professor at UC Berkeley, and my research is at the intersection of computer vision, graphics, and machine learning. And specifically, I focus on reconstructing non-rigid objects in 3D, like animals and humans and their environment. And so, first of all, I was really excited about the photogrammetry article, and I was like, it was really cool. And this talk is really impressed because you have such a full stack development from like user interface, which I really like the scrolling idea. I didn't even realize until you told me about it, how it's really immersive actually, and it tells you the story. And then all of these things into like backend and actual reconstruction. So like, yeah, okay, here I have 2 questions. One, this simple one, which is like, how big many people involved in total? Like if you wanted to capture a site, for example, like how big of a project is that? And like how many people gets involved after, from the conception to the final story?
I think our core team is about 5 people. Please correct me if I'm wrong. And we have about we have a producer. We have 3 technologists that do the capture, and 2 technologists that do like the whole pipeline, and amazing engineers, and also like supporters in the team, also like Lana, the creative director, and Marc, who also supported with like, the right technology, the right tools, using like the best tool that can guarantee us the best result. And everybody has their own like techniques and experience. So when we all came together, everything just work. And then we, as I say, we learn from every project. So we keep fine tuning and tweaking anything that we couldn't do from the last project, and we were like, all right, let's try this in the next project. Like, it's gonna be better. It's gonna be better in terms of like the capturing process, and then the post-processing process, and then the delivery. So it's like the entire pipeline that we keep like fine tuning a little bit.
Ah, this is super cool. Wow, that's really impressive. Okay, so like my next question is really related to I'm really curious about what if you could expand a little bit on like this adding the movement to the scene, because as we all know, I mean, 3D reconstruction is really hard when things are moving around, right? So a lot of the stories involve static scenes. And so like, what do you think you could do if you could also capture humans or people moving around in the scene, and like what your thoughts are like that in maybe like coming 5 years or so?
So that's the question that we get asked a lot and all the time, because once we have the model looks honestly kind of dead, and we always like go to capture the site early in the morning, like to avoid people. But also to like do research, and a lot of times like those research becomes the final result. But back to your question, we are working on implementing different ways and different techniques to add those movement in, whether it's like volumetric capture. Is it gonna be like point cloud? Is it gonna be like a video with like a green screen? Like, we don't know. We're working on it.
No, this is really exciting, and I'd love to talk more about it actually, because I would look forward to going in that direction.
Yeah, if you have any suggestions or ideas, we would love your input.
Great.
All right, I propose Irfan has also prepared some questions. Irfan, are you online? I don't see you.
Yes, I am. I hope you can hear me, right?
Yeah, we can hear you.
Good. So, okay, so for those of you who don't know me, I'm Irfan Issa, and I'm a professor at Georgia Tech, but also the director of the Machine Learning Center. And I also work on computer vision, but the other area I work on is computational journalism. So, as I said, this is basically great to see those two things merge today. A bigger question that I have is, so, one of the things is you guys are creating all of these technologies, while on one hand we have this journalism that's going to as small form as possible, Twitters and all that kind of stuff. But now you're actually also creating these stories that are much more immersive and require people to spend more time with the content to really kind of experience it. Are you seeing that as a growth of this kind of journalism on parallel to the kind of the microjournalism kind of the stuff that is also getting prevalent?
I think part of what we've seen over the last decade writ large is from a coverage perspective, we kind of basically need to be doing all things at all times, and it's grown much more complex than than when we would basically write the newspaper length version of a story and then take that same exact 1,200 words and put it online and put a couple of photos on it. And so I think what we do writ large when we have a big story is think about the different versions of it that would land on different platforms. You can have a reporter write a 3,000-word investigative piece and also write the 12 tweets in a tweet storm to make sure that the key points are disseminated broadly, so that we don't have some content aggregator doing that to us. And so that sort of brings in much more sort of holistic approach to making sure that the right pieces land in the right places. I think one of the roles for R&D in that when we look at some of these new these new capabilities and new technologies is to think about, and Or's done a lot of work on this, and Marc in particular, of okay, you do a 3D simulation. There's a version and a level of detail that you can achieve when you have someone in the New York Times app or you have them on our site that we can get sort of deeper into. And then there's the version of that can travel on Instagram. That might be a little bit lighter weight, but uses a lot of the same underlying techniques and learning to get some of the key points across. So I think that there's, long story short, it's largely an all of the above strategy, but we try to make sure that as much as possible, things that we work on can be used ideally in more than one place.
No, I'm a big fan of long form journalism, so I'm glad to see that you guys are covering the spectrum as opposed to just giving initial bits. Another aspect of the whole storytelling, which is also, my work with journalists has suggested that most journalists like to also kind of write a story as like a marathon or a race, and once they're done, they're done. But now another form that's showing up is, living documents or living artifacts that keep growing. And I think you folks are now developing technologies that can actually continue to grow. Is that the intent, is to kind of create that kind of journalism that is no longer just an end date and we're done?
In some situations, and this goes back, I think, a bit more to, with the prior work, Marc and I previously did interactive news and graphic stuff at the Times. There are situations that or long running stories that warrant that. So you think about we have a whole team of people keeping our various COVID trackers up to date on a daily basis and so on, right? That kind of database journalism. I think we look for opportunities to serve readers that way. We've had a Guantanamo database up for however many years now. What we've learned over the years through a little bit of trial and error is the cost associated with doing that and making sure that these things remain up to date, not just in the care, keeping the data up to date and things like that. But when I first got to the Times, a lot of those things that we had built were built in Flash, and some of these stories run longer than the arcs of technology that they were built in. And so, there's a lot for us to consider in how we manage those things, while also wanting to make sure that the updates, what's actually news, gets out to people as well.
Let's want to follow up, and there's a question also in the Q&A by a friend of ours, Aaron Hertzman, is how can us researchers, and I know I'm part of the computational journalism discipline itself, and we want to engage with you, but how does more professors and more researchers engage with you folks and, as you said, build this community that's interested in both the research and outcomes that you guys produce?
For starters, just please, I think ad hoc hit us up. Our email is rd@nytimes.com, and that's on the site as well. I think we're starting to think about how to do some, use some of the convening power of the New York Times next year. That's still very, very early stage, but we want to be, an active, a more active participant in these communities. So, but for starters, I think it's where we've had success so far is just kind of like starting by building these kinds of relationships one by one.
Thank you, Frank. You want to go through the Q&A that's in there, or?
Well, I've two questions myself, and then I'll go through some of the Q&A questions. So my name is Frank Delaert. I'm a professor at Georgia Tech as well. I've also worked at Facebook with virtual reality and augmented reality a bit. And so I realize this is very exploratory. You're pushing on a number of different technologies, right? So, and I'm just wondering, even though it's very early times, whether you have a sense of what truly excites the largest readership. So where, what stories that you collaborated on really had traction with readers?
Or do you want to talk about any of the stuff that you've done this year. I know we presented a bit of it, but some of the reaction to it.
Yeah, so yeah, I'm happy to talk through some of them. So I think at large, some of the work that we've published on Instagram has seemed to resonate with people. I think to Irfan's point of like short form journalism, I think augmented reality has been used for a lot of novelty causes. And I think when people see a use case that actually gives them a new perspective on a thing, it tends to be it tends to have a larger impact. So I think with some of the spatial data visualization, we've definitely seen good reactions. I think one thing that we sort of thought through is a lot of the times with these data visualizations, they actually help readers visualize things that couldn't have been seen otherwise, right? So the air pollution, Instagram augmented reality effect is a good example. These are pieces of data that exist in our world, but unfortunately or fortunately, due to the limitation of our senses, we can only see so much. And so I think being able to visualize these pieces of information and create compelling spatial journalism pieces around them, we've seen that these tend to impact readers. And so, yeah, this includes the air pollution effect, but also the CDC guideline visualization has had, I think, just being able to visualize spatial information in people's space that they couldn't have seen otherwise has seemed to be sort of a reoccurring motive in some of the work that we do in that space.
Yeah, that's cool. One last question. I'll go to the Q&A. But so a couple of years ago, I read a book by William Gibson, and there was an exhibit, an AR exhibit or an AR story around River Phoenix in LA, and so this was sort of like in situ journalism. So I'm wondering whether, I know you were trying to reach out to many readers at the same time, and so this is difficult, but do you see a future where stories are embedded in space in a particular location? Say, I don't know, the Times Square in New York. There's a New York Times story there about something.
I could try, but Marc, Lana, feel free to interject. I think geospatially tagged stories are definitely something that the editorial teams that we've been working with are thinking about. I think the coronavirus outbreak has definitely posed some interesting questions around geospecific spaces. I think actually a lot of the stuff that we're seeing is in the opposite direction, where because people can't visit a certain space, the capability of being able to show what that space looks like or experience what that space has to offer is actually even more compelling nowadays than it was 7 months ago. So I think the answer is yes, but I think there's definitely some forcing factors in the reality that we live in right now that actually encourage this medium to be more geo-welcoming in a sense, if that makes sense, being able to transport you to a place that you actually technically can't be in right now, or showing you a data visualization of a certain city that you can't visit right now due to the current travel restrictions. So I think the answer is yes, but the current reality has maybe helped us push in a slightly different direction. But that being said, it might change.
I think one thing maybe to add on to that is that I think there's a pattern that the New York Times has done, whereas they have a story that is broad, but you can attach something like local from your location. So the air pollution story, the one that you can do in our app, actually you can show the air pollution results from where you are. There's like various upshot stories where you can type in your zip code and see the data from your perspective. So I think there's a lot of interesting areas there where it's like, yes, we are publishing to like a wide audience, and even with like the photogrammetry stuff, we're like, if you don't have like WebGL, you can't use those articles, which is so unusual for the Times to only support particular so we can't use any of the NVIDIA graphics stuff just yet. But thinking through like how like more contextualized environments could actually help a story that can also be told to like a wide audience.
Yeah, well, this is a question for the two Marcs, really, which is this is a question from the Q&A from Ankur, and Ankur asks, what about the origin story of this team? So can you tell a little bit more about how the team originated, why the Times felt compelled to, to create this this team, and maybe give some insight there?
Yeah, totally. So this is actually the second R&D group. Well, actually, I think the third R&D group that's existed at the Times, at least that we know of in the Times' history. There might have been one back in the 1880s, but they didn't leave much behind. We from sort of like I want to say like 2005 or 6 or thereabouts until 2016, we had a team that was much more of that kind of like 5 to 10 years out. What is the future of media? How do we create a space where people can think much beyond what the current landscape of journalism is? And for a variety of factors in 2016, in early 2016, we decided that we wanted to really flip the model, and instead of it being this like outside in kind of thing, we wanted it to really be like more of an inside outward kind of thing. That we're just looking at so many things that are happening even then, new formats, new areas of emerging technology that felt like they were starting to become real-ish. Wanting to make sure that we were doing essentially what we're doing now, which is exploring them in the context of upcoming news cycles and things like that, but trying to find a sweet spot where folks who have to, for instance, cover the election or cover COVID aren't distracted by these things, but we're doing, we are looking at these things in service of solving for these types of news events, right? So you think about something like the work that we've done in the direction of the Summer Olympics and things like that. So, I think first it was kind of creating the space as that kind of bounding box for us to be able to work with it. And that's a commitment that the company makes out of our core technology budget. So that funds the core team. And then what we've done over the past couple of years in particular is look to grow our efforts through partnerships. And so that can be with other companies, that can be with folks in academia, or philanthropic organizations. In past lives, we've done work with companies or organizations like the Knight Foundation, which funds a lot of journalism, innovation, things like that as well. And so some of the areas that we're exploring and directions that we take are in collaboration with some of these other companies. So for instance, we're working closely with Facebook on the stuff we're doing with AR on Instagram and so on. So that's part of how we've grown the team. And now we have sort of 2 large dedicated groups in flight, and then sort of a bunch of earlier stage kind of bets as we call them. So all told, it's about 24 people.
Cool. So, so a related question, and this question actually came up in the Q&A several times, which is, do you have a sense of how the reporting team, the reporters, the journalists themselves have been influenced by this new technology? So, did you get feedback there, or do they want to work with you? So, can you give us a sense about that?
The analogy I use a lot is like, the first step of this, I think, is a little bit like Tom Sawyer painting the fence, getting them excited about these things that, a lot of the actual work of adoption can be kind of boring, essentially, or things like that. But finding ways to generate excitement and promise around these things. We work in a very, very hands-on way with desks around the newsroom. Everything that you see us do that manifests as journalism is in collaboration with other newsroom desks. We don't do anything on our own. Those on the ground opportunities are really where we're able to, I think, show both the amount of work that goes into something like multiple days of a photogrammetry shoot, but also get folks, the reporters and editors in particular, excited about the promise of being able to tell stories in this way. I don't know if anybody wants to throw in anecdotes from the recent photogrammetry shoots or some of the work that we've been doing in working with our photo desk to sort of illustrate this.
Anecdotes would be great. Right. While you're thinking about anecdotes, there is a question I think that Mint talked about, but it's actually one of my students, Ayush, is asking. It's really awesome that you're targeting real time or close to real time reconstruction. How long does it currently take to do a 3D reconstruction? And so where are we, and where do we have to end up? And either Lana or Mint can take this, I guess.
So it really depends on the scale and the size of the projects of where we're capturing. Let's say the loft. The loft takes about 2 to 3 days to process to get the models once we already have the images. The Abaco model was a little more. It takes about 3 to 4 days to get the models out of the reality capture and upload it to the cloud. So we have a pipeline that so let's say we have a planning, right? We have planning, we go out and shoot, then we run the model in the computer. So while we're running the model in the computer, like we have to use this time, this downtime to talk to the editors and get the story going. And in the meantime, we also have like a pipeline that optimize the high resolution model that will be used in the article and optimized it to like 5 million polygons, and we use that to like create the camera animation or to create any point of interest in the stories that will help the editors start creating and thinking about 3D storytelling in the article, because 3D models is something new and it takes like time to generate the story that like flows. Because we want the 3D models to complement the whole article, the text, the 2D image, and the movies that's already like the elements in the article. And then once we have the final model up, we switch out the low poly. The pipeline's a little confusing, but then we switch out the low poly model and then like apply the camera movement with the high poly count model. So we have like a pipeline and the workflow in the backend at the times.
Okay, that's good to know. And actually, so all students that are listening should take a lesson from this. That is, while your code is compiling, you can do other stuff. Okay, you can use your time creatively and productively.
I was going to say, I thought of like thinking through, like working through with the newsroom on the photogrammetry projects. It feels like it's really exciting when they get their hands on the technology and can really like drive the storytelling part of it. So thinking of the Phase Clan project and working with the visual director on that, Tracy Ma, was like really like driving the aesthetics of it, and also like taking on influences that you wouldn't expect that New York Times, so it had all these like video game references, like, oh, this feels a little bit like Zelda. Like, are we making a version of Myst here? Which I feel like, I think in every project we have, and every like sort of capability we build, we really feel that like the Times journalists are really the best users. They're really critical, but they're also willing to like poke the edges of the technology and really push it forward.
Well, if possible, can I jump in with one more question? Yeah. So, I mean, one of the things that, when data started becoming popular, it led to this whole area of data journalism. Basically, data is used to tell a story. And similar examples exist, and one of the things that you guys now refer to as spatial journalism, we're trying to kind of get space to tell it much more with an orientation of space. One of the things that's always been kind of problematic to me is that, when a journalist stands there and says, oh, the left of here is something going on, now you can actually show where the left is. And you can actually connect it back to where the kind of the concept was. And, and some people, especially when they're doing, journalism up on the field, where the rocket came from there, and they could even be pointing somewhere that there's no there. But now you can actually, so do you kind of start seeing a newer form of journalism kind of come out of this that, would become more prevalent, just like, as I said, the data journalism was driven by data. But I mean, I know augmented reality is going to provide some of that.
I could try, Marc, Lana, and then feel free to interject. I mean, I think there's definitely like new editorial opportunities that when we work with the newsroom, every time we talk about a certain feature, a certain capability, it translates into what can we use this for, right? So I think, a part of that is us really trying to assist with the translation. But I think, to your point, there are huge opportunities, whether it's in spaces like breaking news events and spatial storytelling, or forensic journalism and spatial storytelling. I think that these types of data visualizations actually help shed light on things that require the space to tell the story in a way. So I think there's definitely patterns that emerge from that. And I think a lot of it has to do with technologists working with the newsroom so that, together we could actually help them unlock the story opportunity in some of these spaces. So really taking the capability and figuring out, like, could this be used in a production story? Could this type of data be imported and visualized in a way that would feel meaningful? So I don't think I have like a clear, like, here are the 5 things, but I think every conversation with the newsroom where we talk about capabilities or technology opens new opportunities in these spaces.
Yeah, I'd like to jump in this one for a little, because like or at least from my side, I think I'm the kind of like developing technologies that at the layers of the reality capture, or like the next reality capture kind of things, right? But then I think we tend to think like, oh, we're going to do this capture without really thinking about the after use case of this. So since this article, I've been thinking about how can we actually get the human stuff in there, and like what does it really mean to do that? But like after talking to you all, it's more like it doesn't actually have to be the absolute reconstruction of the person. Maybe the way you would visualize it really also depends on the story, and that kind of like back and forth between the tech or the researchers and the journalists or the story users, I think find it really interesting. And like I don't know, this is just a really comment, and I wish I had this kind of more conversation so we could think more innovatively about what kind of representation that we want, that's not necessarily like the perfect one, but is actually good for telling a good story.
Yeah, 100%. I just wanted to throw in one more thing, is that I think when I joined the R&D team, one thing that struck me as a surprise is that a lot of the journalists who work at the Times are also technologists. And so I think it is in a lot of cases, they can already visualize part of the picture, and we can help with maybe the building the pipeline or imagining how data would come into it. But I think it's there are all sorts of types of journalists who work at the Times, and so I think it's also more of a conversation rather than a pitch, where I think that a lot of the journalists that we get to work with are really open and know about these things and have some level of familiarity with the ideas. So that it makes it in some cases easier, and in some cases it even, they could have the idea for what they thought, we should try and do that.
Yeah, actually, so one last comment, and then I'll hand it off to Irfan to close out because we're getting signals that we have to finish up. So first of all, it's been an incredible honor to hear this from you guys. We've seen these articles as technologists. We are in awe of the articles you bring with this technology, and it's just such an honor. Irfan, do you want to finish up?
Sure.
Yeah.
Yeah, let me, I wanted to echo what Frank said. Is it's always great that, we build technology that's, kind of out there without really knowing what it could be used for. And then people like you actually build technology from scratch, hopefully picking up on some of our concepts and ideas. And that's where we're there to help you do more of that kind of stuff. And then make something beautiful like the ones you showed that actually is being used by people and actually has real value because they understand, the concepts around them. And, it's about citizenry and stuff like that. And that's one of the things I really like about journalism. It's valuable information for citizens to use in their daily lives and stuff like that. So I think it's great that you folks do this. I wanted to thank you very much again for joining us. I've got a lot of good questions. There are still a lot of questions coming in. We won't be able to get to all of them. We'd love to engage in more conversations with all of you as much as possible. So Marc, Lana, and Mint, thanks for doing this wonderful talk. I also wanted to thank Frank and Andrew for helping set this up. Again, there will be a lot more conversations like that. And also thanks to the entire audience who joined in today. And I also wanted to thank Ali and Catherine and others who actually helped us organize this. With that, thank you so much, everyone. The only people who can applause is
thank you.
Thank you.
So much.
One other shout out to Justin from the Times side who ran the deck for the last 90 minutes as well, and set this whole thing up on our end. So thank you very much to him. The behind the curtain. Have a great afternoon and weekend, everybody.